So, hello everyone, this is the continuation of the 32-bit processor designing in the Vivado using the Verilog language. So, this is the rag file module, that is register file module, and this is the fourth module in the continuation. And now I'm explaining the source, the main source code of this reg file, that is this. Now we take input all wire. Why? Because we are not saving any value to it. These all are given to the reg file, so it is represented in the physical wire manners. That's why we define all of them as wire. And why we take the R2 R1 these register as 5 bytes, because this is 32-bit processor, so if we power the 2 to n that is equals to 32 bits, so it will give us 5 bytes. Now, this we declare as 32 bits. So these are the operation. And now this statement. Carefully look at this statement, that is rag 31 is to 0. That means one register that is of 32 bits, and the registers 0 is to 31. That is, we are allocating the memory in the form of array to the registers. So it will goes like memory index 0 to 31. So for all 32 bits register, right? Now initialize I for the loop. Why we apply the loop here? To initialize all the registers from 0 to 31. Why? Because the register 0 is not initialized by any value except 0, and is permanently fixed and initialized to 0 in the processor, right? So for loop we have applied, and we are stored we initialize it with the 0. Now we assign the read data 1 with the registers read R1. That is, suppose we have register with index 8. So uh, read R1 receives R8, and in that register we read the data. That means we assign the data in that register. So that is the read operation. We read the data. Suppose R8 is equals to 100. So in the R8 we read the data 100, right? So this is for the read operation for both the registers. Now this statement always at the rate post clock. So why we write this? Because this read operation is happens in a sequential manner. Sequential operation we are performing. So for the sequential operation always occurs at the rising clock age. So for the rising clock age, we write this line. And this begins here. And if the reg write, that is, we are enabling the write operation here. And we apply the condition that write R is not equal to the 0, 0. That is, that what that means, that except the R0, we're not including the R0. अगर R0 नहीं है, then we enables the write operation, because we cannot write in the R0 because it is always fixed to 0. So we write the data in this manner, and this is the end module. Now the test bench file. So we created all of them, and this we declare rag, because we are now giving the out we are giving the values to it, right? And these are the outputs. So we initialize, or we write wired in front of it, because now we are not having any value stored in both of these. Now we created the module instant, and through that we make the reference of all the input and outputs. And this is the main file name. And this is the clock that we applied, and the initialize the clock, right, and all the operations in this manner. Now this is our simulation diagram. So for 00 register, we give the 00, and for the 05 register, we give the 100. So this is not hexadecimal, so it is 64 that you're seeing at the end. And these all values are in the hexadecimal form, and it is doing the same operation as I already earlier explained to you. And now see the semantic diagram of it. This is the semantic diagram, and this is perfectly right. And this is all about the register file module. I hope you understand every point. If I explain something in a wrong way, please correct me in the comment section.